Good afternoon, KubeCon. How are we doing? So, before we get started today, Cailyn's going to take a quick selfie with the audience. That's all right? Ready? OK. On 3.
Flex
1,
if you're up for it.
2, 3.
Woo! I think maybe a little more. Woo, woo, woo! Awesome.
All right.
So I would not have worn this outfit if I knew how many people were going to show up. But I'm here, and I'm in it, and I'm so happy to see you all. Thank you so much for taking the time on the last day of KubeCon in the afternoon to come to our talk. It means the world to us. So what are we talking about? I assume this is why you're here. It's the title. It's funny. And that's what we're going to go over. This is an entry-level talk going over the risks of containers if you just make them and you don't necessarily know what you're making. So we will kick off with our introduction. We are your coaches. My name is Cailyn Edwards. I am a security engineer at Auth0 by Okta, and also a co-chair of Kubernetes SIG Security, a CNCF ambassador, a very enthusiastic dog mom, and a Sander fan. I've got my Bridge 4 earrings on. If that's a reference you appreciate, then we should be friends. And I will pass it over to Dan to introduce himself.
So my name's Daniel Murphy. I am also a senior security engineer at Auth0 by Okta. I am a lover of photography, coffee, and outdoor adventures, and also a massive Sander fan.
Okay, so what are we going to go through today? We will start off going over the lingo. We're going to go over the what, the how, and the TLDR. We all know that the Kubernetes landscape and the software landscape in general is full of overloaded terms. So let's break them down and make sure that we know what we're talking about. Next, we're going to go into the before. We're going to meet this soft and vulnerable container, get to know what they've got going on under the hood. Finally, we'll get into what you're all here for, which is the montage. We're going to take that container from squishy to strong. And then we'll finish off with Coach's Corner. We're going to offer some tips to take forward to your company, to your personal home project, so that you can secure your containers and have rock-solid, show-worthy containers. Finally, I'll start with the lingo. As I said, we want to make sure that we're all jumping into this presentation with a shared understanding. If I say any words, I want to make sure that you are thinking of the same thing that I am thinking of. Starting off, because this is KubeCon, we'll go through the Kubernetes components. At the very top, we've got the cluster. That's where everything lives. That's right there, a collection of worker nodes. Then we've got the node. These are your workers. They can be virtual or in the cloud. And then we've got the pod. This is the smallest deployable resource in Kubernetes, and this is where your applications live. And then finally, we've got the container, which is a lightweight unit that contains all the components needed to run an application, such as the application code, runtime, libraries, and configuration.
And a few terms that we're going to be using that are kind of container security specific. So starting with base images. Images, like onions, are made of layers, and almost all are based on another image. We have our dependencies, so these can be operating system or your programming language packages that are used by an app to do what it does, and these can be direct or indirect, and it's dependencies all the way down.
Dependencies, ooh, supply chain is so hot right now.
I know, right? We've got vulnerabilities and exploits. These can sometimes get used interchangeably, but when we say vulnerabilities, we mean weaknesses in software that can be used to do something that we don't want to happen. And exploits are essentially tools to take advantage of them. And lastly, scanners. So these are just a specific type of tool that are designed to examine your container in some way to detect things like insecure configuration, things that look like they might be secrets, vulnerable packages, that sort of thing. And so why does this matter? So I did a bit of a lit review in preparation for this talk and found that a study from 2021 found that nearly half of the official Docker Hub library images that they studied contained at least one vulnerability that had a proof of concept exploit. So by that, I mean an exploit that can demonstrate that this thing is actually usable, but has not been built to do something actively malicious, like exfilling all of your credentials or starting up a crypto miner. And in a different study from 2023, they found that about 30% of popular Docker Hub images were based on a parent image that was outdated by over a month by the time the child was built. And 70% of the latest versions of those images were built from an outdated parent with a median staleness of more than 5.5 months.
So probably we should just use latest all the time?
About that. So in yet another study from 2020, so all of these have got links at the bottom for sources that will be on Shed after the show. So there's nothing actually all that special about latest. It's only created if you don't specify a tag when you're building the image. And it only gets updated if the maintainer of that image remembers to point latest at the version that they've just built. So when you track latest, you're relying on someone else to dictate which image version you're actually running. So this study found that nearly 12% of images that they looked at had a latest tag that doesn't point to the latest version, and about 4% had a gap between latest and actual latest of more than 5 versions. So there is kind of a problem here. In yet more data from 2023, secrets, turns out they show up everywhere. So of the roughly 340,000 images that were studied from both Docker Hub and quite a number of allegedly private but unsecured registries on the public internet, they found more than 28,000 of those images had at least one valid secret, and they found a total of 55,000 secrets. So most of these were TLS and SSH private keys, a couple thousand cloud API keys, hello crypto mining, and a couple thousand compromised certificates. And those secrets, they stay in use. So a couple hundred of those certs from public CAs and nearly 5,000 of them from private CAs were still valid when the image was pulled for the study. And more worryingly, like 275,000 hosts were still actively using these keys to secure services. And these were like HTTPS servers, SSH, or Postgres, LDAP, MQTT.
Oof, those are some big numbers.
You haven't seen anything yet. How about 1 million? 1 million exposed container components on the public internet. Data from 2024 found more than 1 million of these exposed components, and by this they meant REST APIs like the kubelet, the Kubernetes API server, image registries, Docker runtime sockets, or etcd clusters. Of those, the majority were running outdated versions and using default configs, which is a recipe for disaster when it comes to vulnerabilities. About 750,000 of them were kube API servers, 250,000 kubelets, and these are things that, by their design, are supposed to give you remote code execution as a service. And 86% of them were, 86% of the exposed kube API servers allowed anonymous auth. And this is because from version 1.6, the default has been that if you have an authorization mode other than always allow configured, then anonymous auth is also enabled by default. You can turn this off, but because Kubernetes is declarative, it's going to take some liberties if you've not specified certain pieces of configuration. It doesn't default to the most secure option. Instead, it's going to sometimes pick a more usable option so that you're not pulling your hair out trying to work out why something isn't working. So we need to be very intentional about ensuring we secure our applications properly. Now, of these 1 million components that they found, about 1,000 of them were on public IP block lists from threat intel providers, which means we've got a pretty good indication that threat actors are taking advantage of these services to do bad things. So now, Cailyn is going to introduce our lucky example container. So if we could have a drum roll, please.
More, come on. All right, this container loves sharing secrets. It takes candy from strangers, gives its one-time password over the phone, has sent Amazon gift cards to princes in faraway lands, and has the same password on all its accounts, kept in plain text, on its phone. It's soft, it's fuzzy, and it's going to compromise your applications. Introducing Squishy Bin. Please don't hack.
So let's take a quick look at what makes this Qt so squishy, starting with our Docker file. Now, the application that we've containerized here doesn't really matter. In this case, it's a Flask API that returns a string, but we're trying to demonstrate how we've containerized it and how we're deploying it. So we're starting from a fairly slim Python base image using Alpine from the Docker Hub library. We're setting up our workdir, we're copying across a pip config so that we've got access to our private registry, installing our dependencies, get rid of that pip config, copy across the rest of our app source code, set up our entry point, and we're off to the races. It's pretty small, can't be much wrong with that, right?
Oh, it's me. Right, yeah, so it's a little baby application. It's not doing too much. We're going to look right now, again, KubeCon, at the Kubernetes deployment. Here you can see we've got a pretty standard deployment. It's got a namespace label, great job. It's got all kinds of basic settings, and this could have come from anywhere. This could come from the Kubernetes.io docs. This could come from your favorite AI.com, whatever it is. This is a really normal configuration, and there's nothing wrong with using it. Before we get our little friend into fighting form, we need to get an idea of where we're starting. So for the sake of the metaphor, this is equivalent to getting a read on our body composition or doing those awful before pictures, doing our 1-rep maxes. Dan's going to take us through the results and give us a good look at where this squishy bin is starting.
Thanks, Cailyn. So first, we're using a tool from a tool called Trivy, which is an open source tool from Aqua Security, and we're using this to scan our images for any known vulnerabilities or misconfigurations. And as we can see here, we have got a couple of vulns that we need to take care of, including a pretty high severity one there that we will come back to in just a minute. We are also going to point a tool called TruffleHog, which is another open source tool from Truffle Security, to scan our images for any secrets that might be lurking there. It can find all kinds of secrets in all kinds of locations, even though we're just looking at an image today. But I'm not sure if it supports Signal group chats just yet. And as you can see here, so much for our super secret password, right there in our pip config. So Trivy can also be deployed as an operator to your cluster, and in this case, it is scanning for the cluster components itself, the workloads that you're running on it, the infrastructure that sits underneath your cluster, the RBAC configuration, and it creates custom resources in etcd, which means you can consume this programmatically in any way you choose. So I realize this is a little bit hard to see, but this is a sort of overview of some of the findings that we've got from the Trivy config report. And in this case, we've got a mutable root file system. We've got things like no security configs configured. We can escalate our own privileges, and we're running as the root user. We've got an ID for the check. We've got a little description of what's going on here, and a message giving you a bit more details of exactly what you should do to try and remediate this. And these are just some of those zoomed in a bit so that you can read them a little bit easier. So that vuln that we looked at earlier, who doesn't love a CVSS 8.8 remote code exec in their package management library? So CVSS, for anyone who's not familiar, is the common vulnerability scoring system. It takes a number of factors about a vulnerability, such as what network conditions it needs, whether it compromises confidentiality, integrity, or availability, that sort of thing, and gives you a score from 0 to 10 to give you a rough indication of how severe a problem is. So our demo app is pretty small and has a nice shallow dependency tree, but who here remembers the log4shell vuln and the pain of responding to that incident? So time for our montage. Let's lift some water jugs and get this container in a better place. Starting with some quick wins, we're going to patch almost all the things. So taking recommendations from any scanners that you've used and updating your image version. But some things to bear in mind when you're running these updates. If the thing that you're updating adheres to SEMVer, or the semantic versioning standards, that's like major, minor patch, that can be a really good way of trying to get an indication if what you're updating to is going to have breaking changes in it, if that major version number's changed. Also worth having a look at release notes for any of your sort of critical dependencies, because they can also highlight when things that aren't necessarily breaking changes but will affect you are going to be in the release you're updating to. Make sure you don't accidentally run alpha in prod. If you do, you're a braver person than I am. And just because it should just work, please test your application. I can't tell you how many things I've been told should just work that didn't. Big shout out here to endoflife.date, which is a really great online reference for a bunch of projects, their supported versions and like support dates for when those versions are going out of support. As well as Renovate from Mend, which is an open source tool that will help automate a whole bunch of different types of dependency updates, not just security relevant ones. Cailyn?
Yeah, and fun shout out. I actually mucked this up when we were preparing the demo and went ahead and pulled a alpha version that was not latest. So just because you're in the field doesn't mean that you're just going to do things correctly all the time. I think more even than bad actors, we need to watch out for not having paved paths and guardrails, because we all make mistakes. We're all tired, overworked, and excitable. So let's get into some of the changes we made to our Kubernetes components to ensure that Squishy Bin gets nice and secure. The first thing we did is another quick win. We just chucked Squishy Bin in its own namespace. This is a really common strategy in Kubernetes to ensure that these multi-tenant applications that are sharing resource space are not actually accessible to one another. So this allows us to have bespoke security policies for each of the workloads that we're running. And you can see right here, it's as simple as adding a line to the deployment. We can see this in action right away with our next step that we took for security. In the namespace, we can go ahead and add some labels through the pod security admission controller. This is a native Kubernetes feature. It's been available since 1.25. You can also configure the security admission controller in the YAML. We all love YAML and want to be there all day. I love YAML. But we don't have time for everything today, so I've just done a really basic example. You can see the top labels there say enforce, and I think that's pretty self-explanatory. That's going to go ahead and enforce the pod security level, and this is baseline. This is just kind of your, okay, you've met the minimum security requirements, and then below we have two other levels set to audit and warn. And so warn is going to warn the user when they create resources, and audit is going to add it to the event logs. So we'll go ahead and take a peek at what this looks like. So first we will look at the namespace itself. We see those labels. We've already talked about them. So there they are. And then we will move on to looking at our pod definition. For these examples, I've made just some kind of risky business pods, bad pod. You can see it's got a security context, but it's commented out. It's not really doing much lifting at the moment. And the security context that is set there is unconfined, which is the most risky one, but it's not, it's commented out. So we'll go ahead, we'll create the pod. We get a warning because it has no defined security context that it would violate the more advanced restrictions. So we'll delete that pod, and then we will go ahead and uncomment that security context, I think, maybe. We'll see. Could be a surprise. Oh, yeah. I know me. And then we will go back in and see if we can create the pod again. No luck, could not create it. So this is really nice. If you have very risky workloads and you want to ensure that your security policies are being met, you would do something like this that enforces. If you want to get even further, you can use tools like Gatekeeper or Kyverno or Kubernetes to do the same thing. The examples I'm using are Gatekeeper, but there's lots more that you can use. All of these examples come from the Gatekeeper policy library, and there are loads there that would probably work in your job and also, again, for your home lab. And so the two main types of admission controller are validating and mutating. We'll start with validating. This just means that it's going to perform a check when there's a change on a resource and validate that it meets whatever policies that you have set. We've started out with a very basic one with the seccomp secure computing mode profile. Runtime default is kind of, again, the default basic profile. And then localhost would mean that you're grabbing the localhost profile and it has to be available on the node disk. We've allowed all localhost files because we don't give a hoot. And now, again, we will go ahead and watch this in action. And so I will apply the policy. This is all made to run like all of the Kubernetes. We've got a YAML file. We're going to apply it. The constraint is created. And we will take a look at it. Oh, no, we'll take a look at our bad pod. Same bad pod as before. It's got that unconfined profile, which means no holds barred. It can do whatever it wants within reason. And then we will go ahead and try and create it. You can see that it is denied because of the seccomp policy that we just added. Now we will go and we'll add this exemption. And so I wanted to highlight that you're able to make exemptions because not all your workloads have the same security requirements, and it's very likely that you're going to have some things that need a little bit more of a permissive security policy. And this allows us to secure by default and start very secure and then open up where we need rather than lock up and then secure where we can. And you can see now that we were able to successfully create the pod. Woo! Next, we will look at the mutating. So same sort of thing. We have a policy, and in this case, the policy will make changes based on a set of criteria. This is a very simple one. It's going to look and see what the seccomp profile is set to. If it does not exist, it will set it to runtime default. And we will watch that in action as well. And this is really powerful because it means that you are taking some of the burden off your developers and ensuring that your minimum security requirements are being met. We're going to look at the pods. We made the pod. It was able to be created. Now we'll delete, or we'll look into the details of it and see that it does not have a seccomp profile set, which is what we expect. Now we'll delete the pod, and we will add our policy. Applied our policy. So now it should pick up that the pod does not have that seccomp profile set and set it, maybe. I'm just kidding. I know what's going to happen. I did this. And then we scroll up, and there it is.
Ta-da!
Magic. Very, very, very powerful.
And so we've already touched on updating the image that we're using, but we've also made some other changes to our Docker file, starting with that pesky pip config. So instead of copying a file into our container build and then trying to take it out and leaving it behind in another layer, we're instead taking advantage of the ability to mount a secret at build time, and it will then be available at the path that we were previously copying it to, but not get added to a layer in the final image. We've also added a user so that we are no longer running as root. And we've set up a health check so that our container runtime can tell if we are still alive or not. It's not shown here, but a quick shout out to the Docker ignore file to make sure that you don't accidentally copy your virtual environment on node modules if you're going to be installing them in a container build anyway, or more importantly, things like an envrc file, which some of us use to manage different environment variables and project settings as we're moving around different projects on our disk. And those usually have secrets in them. And that trusted host stuff, you can ignore that for general use. That's just an artifact of how we've set up our demo environment. It's just telling the container runtime to just ignore any TLS warnings while we're doing our build. We are also making some improvements to our deployment. So we are now pinning our image to a specific digest to avoid any risks associated with mutable tags. So if a threat actor somehow got push access to your image registry, they would be able to potentially push poisoned versions of images, overwriting existing tags, and then when you spin up your workload, you're pulling not the image you think it is. By pinning to a SHA-256 digest, if anything at all in that image changes, we get a completely different digest, and our deployment will fail. We also make use of very high user and group IDs to avoid any overlap with the host range. We are running on a read-only root file system. We're blocking known privesc. We are dropping capabilities where we can. We're applying a seccomp profile, and we're applying some resource limits to prevent things like RDOS or cryptocurrency miner from exhausting our cluster resources and generally wasting electricity. So, introducing Cailyn container. This container background checks its friends and family. It has a YubiKey in a safety deposit box in case it's deaf. It doesn't own a single IoT device, and it sleeps in a Faraday cage. It's tough, it's unapproachable, and we might have actually compromised reliability to get it this rock solid. Meet Cailyn container. So, time for a before and after. Everyone loves a before and after, and by this we still mean scans. And we're going to see how Squishy Bin has made its transition to catching container. So before, we had a bunch of vulnerabilities that we needed to take care of. And now, no more known vulnerable packages are installed. We have a CIS benchmark of our K8s cluster and our workload deployed on it. And now, it is clean, it is fresh, it is all passing. Now, this is just our namespace. Your control plane or a multi-tenant cluster is probably going to have requirements that mean that you're not going to perfectly be able to meet every requirement on a benchmark. So you're going to need to do some risk analysis and some bespoke enforcement based on the workloads that you are trying to run in your environments. But don't let perfect be the enemy of good here. Applying some of these controls is still going to put you in a much better place than doing nothing at all.
Awesome. So now we are going to hop into the coach's corner. For those of you that work in security, how do you do this on the scale that you need to across multiple teams, multiple stacks, multiple needs? We're going to give you some tips to ensure that your container security program gets you the results you've always dreamed of. So tip number one, just like when you're trying to get that rock solid bod, you want to make sure that the healthy choices are the easy choices. And in the case of container security, or any security for that matter, we want to make sure that the secure choices are the default choices. In practice, we, being security engineers and security teams, don't have the time to go through every single Docker file or every Kubernetes YAML or run scanners in our terminals like we just did. What we really need to do as security professionals is ensure that we are paving the roads and putting up guardrails. We should have a private registry of blessed images, but also ensure that we're making sure that we want and are getting the images that we depend on. We should ensure that we're patching and upgrading our images regularly, that we're enforcing the use of slim and minimal images, ensuring that dependencies are only included as needed and they're vetted when they are included. Finally, have scanning in your pipeline and alert when containers need to be patched and upgraded. Don't trust that a security review on the creation of a service is going to be reflective of what that service looks like in a week, 3 months, 3 years.
Next, it's important to make sure that you understand the use cases and goals of your customers. And by this, I mean the developers that you work with. Ensuring that you are fully aware of the processes that you're trying to secure and reducing friction in any way you can, meeting teams where they are and adding on to any existing workflows they might already have. By communicating early and often and involving users in the process, you can avoid the nightmare scenario of deploying a control and then disrupting everybody's ability to do their job. There is no faster way to upset a company than doing that. And a really great way of doing this is by running threat modeling sessions with your teams. It gives you a great opportunity to really understand what these teams are building, and at the same time, it gives teams an opportunity to think like the baddies, which can be both enjoyable and quite eye-opening.
And building off of threat modeling, that's a great way to educate teams and encourage buy-in. If you take time to learn about their application, which presumably you will do when you're building a threat model, getting them to data flow, getting them to work through the data flow of their application, you're going to learn a lot about their application. And then when you present the threat model, you're able to offer relevant and valuable insight. And hopefully they're going to be really enthusiastic to action those items because you came up with them together. We all know that the most secure application is one that's turned off, but how can you use the turned off application? And when we make assumptions about developers and the teams and the tools they use, not only do we damage relationships, but we also risk impacting our customers, which at the end of the day, none of us want to do. We want to create a culture at our companies that values security. We're both really lucky that we work at a security company and security is in our blood, in our bones, but that's not always true. You might build something and not think that security is necessarily the priority, and when security is successful, it's silent. You never hear, oh man, it's been 6 months and we haven't been hacked, but you hear the day that there's a compromise. Everyone knows about it. So we need to make people know that we're doing stuff. We're doing stuff all the time. Please, keep employing us. We need it. And then a way to do this in a mature level is to create a security advocate or champion program. This can be as formal as you want. It can be pretty casual, but you bring members of various teams in, educate them about security, and then you have like this mold, your person on the inside who's going to be able to represent the security interests and also come to you and be like, hey, we're doing this. I'd love to hear if you're going to be mad at us in 6 months, which helps us to stop showing up at launch day being like, hey, no, sorry, and gets us involved early. Run security educational sessions, do Cybersecurity Month. It's so fun. Every single person loves the CTF. You just have to make sure they know they're welcome to try. And then completely unrelated to the talk, Annie Murphy was on my train here in Canada, which is very cool, okay?
And so we're going to start wrapping up now. So these are some of the tools and resources that we found really useful during this. Big shout out again to endoflife.date. I use that like all the time at work. Sheol, which is a CLI tool for scanning for end-of-life software or software that's about to become end-of-life. Open Gatekeeper, Trivy from Aqua, Trufflehog, love Trufflehog, and Helm, which made it so easy to get started with the Trivy operator in our cluster. Saved us so much time.
And Gatekeeper.
And Docker and Kubernetes. The Docker desktop integration with Kubernetes gave us a really easy demo environment. But there are plenty of other tools, Kyverno, confidential containers, and all of our, so the slides are already available on Sheds, and we've got some of the resources in our repo, but we'll be adding some more when we have a chance to recover. Cailyn has to get back to Canada. Personally, I'm probably going to need a couple days of hibernation to recover, but everything will be on Shed and on GitHub.
Perfect. So if you're really amped up about security, which I hope you are, I am, I'm pumped, join the conversation. You don't have to just do security at your company. You don't have to do security at all to help with security. You can join me and my co-chairs at Six Security. That is the Goose QR code where you can come to the Kubernetes Slack and talk to us about the security, come to our meetings, hang out, and help improve the security landscape. You could do it at the CNCF level through tag security, but we would really love to have you, honestly. We would love to hear your opinions. We would love to hear your problems. Please come join us and make security better. No, make Kubernetes more secure. Security is the best. So thank you so much for attending. This is the QR code for feedback. If you've got comments, concerns, we have a tiny little bit of time for questions maybe if you have them. Otherwise, you can find us. I think we'll be easy to spot and we'll be around.